hypothesis testing of a population proportion using the probabilities method. A hypothesis is an idea which we test with evidence. The evidence can come from a census or from a random sample. In the majority of cases, we do not carry out a census, we take a random sample, and this is what we'll focus on. There are two methods to test a population proportion: the probabilities method, which is straightforward, and the critical regions method, which is a little complicated. So starting with the probabilities method. So we start off by stating our hypotheses. In 1990, 15% of new cars sold in the UK were red. So here is the first hypothesis, the null hypothesis, the no change hypothesis, H0. P is a proportion and it's equal to 0.15, a value between 0 and 1. We don't write percentages here. In 2020, we think less than 15% of new cars sold are red. This gives us the alternative hypothesis called H1. So P, the proportion, is now less than 0.15. So we take a random sample. So we randomly selected 50 new cars and we found that 4 of them were red. This is called the test statistic. TS equals 4. If H0 is true, then out of the 50 cars, this is the proportion that will be red, where X represents the number of red cars in the sample of 50. So on my number line here, X, the number of red cars in the 50 that were randomly selected, could be 0 or any other value up to 50. The test statistic is 4, which is the number of red cars in our random sample of 50. The mean of this binomial distribution is n times p, which gives 7.5 here. We need to calculate the probability of this region, px less than or equal to 4, which is 0.1121. We compare this probability to a threshold probability called the significance level. In this test we're using a 5% significance level, which is the most common value that's used in hypothesis testing. Other values may include 1% or 10%. So we need a way to compare our probability here with the significance level probability 0.05. So if we find that this probability here is less than the significance level, we reject H0. And if we find that this probability is greater than the significance level here, we accept H0. That's how we reach a test conclusion. So we make a comparison and we find that our probability is greater than the significance level. So this condition has been met, which means we need to accept H0 for our conclusion, and it has to be a conclusion in context. So we accept H0 and we state that there is insufficient evidence that the proportion of red cars is less than 15%.